Okay, and with that, I think we'll get started. So, my name is Mike Dewar. I'm a data scientist from the New York Times R&D lab, and we're going to have a look at the very initial bits of starting to use D3. Please come say hello to me on Twitter, and like I said, if you're interested in following along, we're going to be using I'm sure this is going to be a terrible idea, but there's going to be live bit.ly data coming into this presentation, and I'm going to code some bits up against that live. So I'm just going to apologize terribly in advance, but it's been working okay today. But yeah, do follow along. If you'd like, you can clone this repository to your heart's content. So this is me. This is my history. Like I said, I'm currently a data scientist at the New York Times R&D lab. I started my postdoc career at the University of Sheffield in the UK, went to the University of Edinburgh, then Columbia University, then a couple of years at bit.ly in New York, and ended up at the New York Times. There's been, over this period of time, there's been quite a strong shift from the early work that I did in the universities, where we would get large data sets, so we would get big data in some sense, but they would be fixed large data sets that we were trying to analyze, trying to get insight out of in one way or another. And one of the most fantastic ways of doing that is by using visualizations. So using visualization to explore the data, to explore the models that you're building. But these were fixed data sets. You tried to squeeze them for as much analysis as you could possibly get out of it, and then move on to whatever the scientists gave you next. More recently, though, at bit.ly and at the New York Times, we're dealing with data streams. So we're starting to think about data that comes in at a great rate. So this is stuff that I'm sure you're all very aware of. We're dealing with these streams of data that we're trying to analyze instead of these fixed data sets. And so from a visualization point of view, it presents some new challenges. And so that's why we've started looking at much more modern visualization techniques. So with the old data sets, we would use MATLAB, we would use Python and Matplotlib, or we would use R and ggplot. For these streams, though, those tools are not helpful. So we move on to the new round of visualization tools that are coming out of, and the most excellent one, in my opinion, is D3. So D3 is this JavaScript library by Mike Bostock. Mike also works for the New York Times, except over on the West Coast, which is a terrible shame, so we can't go and find him and shake him when we get stuck. D3 stands for Data-Driven Documents. So we normally think of D3 as a visualization package, but in actuality it's more than that. It's for whenever we've got data that we want to join with web page elements. So we can join data that we've got up to HTML elements, SVG, and Canvas. And it's a fantastic library. It's as hopefully we're going to see. So there are three reasons why I think it's brilliant. It has an amazing community around it. So whenever you get stuck, there are plenty of people that are there to help. And this community has grown amazingly over the last few years and doesn't seem to be stopping anytime soon. It's very common for whoever you want to look at your visualization that you're building. It's very common that they're going to have a modern browser that can render SVG. So it's really, really useful to use a tool like JavaScript to build these visualizations, because the people that you want to see them can probably see them already. They don't need to install, for example, Flash or something like that. So we can use tablets to view these things, smartphones. As long as the thing is running a modern browser, we're good. And D3 is a very low-level library. So we benefit from all of the existing web tech that we've come to know and love. So D3 doesn't reinvent any wheels. We use CSS, we use existing JavaScript, we're using existing HTML, SVG, and Canvas elements to build up our visualizations. So I think D3 is good for these reasons. And so I'm always excited to try and introduce it to people that haven't met it before. What I'm going to do today is get over the initial, hopefully lead you over the initial learning curve of D3, which, at least for me, was, to be honest, a bit of a bastard. It's quite tough to get over that initial curve of getting your first visualization up. Once we're over the thing that I'm going to go over and over and over again today, the rest of it is really pleasurable. So what today is not about is either JavaScript. I'm not a JavaScript developer. If you are a JavaScript developer, I apologize. I don't know when I'm supposed to put semicolons in, and I haven't learned, and I don't care. And if you care, then you can clone this repository and just have at it. Make a pull request, maybe. The other thing it's not going to be about is graphic design and beauty, which is a terrible shame because there are really good designers working with D3. You should go to the gallery on the GitHub page and be inspired. Unfortunately, I'm not a graphic designer, so I'm using this for exploring data and for Bitly and the New York Times monitoring the data that's coming in to try and understand something about it. So there's not going to be beautiful JavaScript or particularly beautiful design. What we will do, though, is this. So I've got 40 minutes worth of material, so we had an hour slot. Do jump in with any questions that you've got. These are the points that I'm going to try and get across. We're going to join HTML and SVG elements with a data set. We're going to draw a map. We're going to use WebSockets to communicate with a stream that Bitly makes available that I hope to God is working right now. And we'll talk a bit about transitions if we've got time. And I'm going to do all of this in the Chrome Developer Toolkit because I want to just make it clear that the toolkit is a really useful way of sketching these kind of visualizations. So I'm going to demonstrate that live with any luck. So this is the stack for today. Do feel free to curl this endpoint if you want to have a look at the data that's coming off of Bitly. Unless you think it will put load, you guys know much more about this stuff than I do. Unless you think it will put load on this endpoint, and then don't curl this endpoint until we've finished. So I'm using a Python reader which is really a tiny amount of code using the fantastic requests Python package to make a long-lived connection to the stream, and then I'm sending all of the valid clicks that I get from that stream to a Tornado instance, who is bucketing up the clicks into groups of 5, and then sending them through a WebSocket to the client. Okay, and all of that is running like quite literally right now. So here's a terminal. There's a Tornado running on the left, on your left-hand side, and hopefully clicks should be streaming past at a wonderful rate on the right-hand side. I'm gonna. Oh, it did? Oh, it did not. I have a backup, but it's random clicks that I'm just going to simulate. Oh, it did not. All right, well, we'll get to that in a moment. Stop typing, please. Shit. So this is the stack. Any questions? It's dead simple. It's all in the GitHub repository. We're using WebSockets to do the last little bit of the connection into the browser, which means that we're not going to have to refresh the whole screen every time new data arrives. So in the clicks that we're going to see, hopefully if the stream wakes up, or random sections if the stream doesn't wake up, this is the JSON blobs that Bitly sends through the stream for us to have a look at. This is almost everything that Bitly knows about the click when it occurs. So you can see, user agent, countries, time zones, logons, host header, which is where the click is coming, which is the short link that's been used for the click, URLs, the time the click happened, the time the hash was created at bit.ly, the country, and then a latitude and longitude. We're going to focus hopefully exclusively on the URL and the latitude, longitude today, and mildly on the user agent. I don't need to say this to this audience, but I'm going to say it anyway, because just in case there's one person that will benefit, because I wish someone had told me when I started doing using D3. The rule that I want to get across is to never store any kind of data in the keys of a JSON object. So apologies if you already know that. This, for example, if you're trying to draw a time series in D3, is bad. You don't want to store the time points in the key of the JSON blob. You want to store it like this. So you want to mark the keys with whatever data you're storing, and then store the data and the value. If you don't do this for D3, especially, you're going to run into problems, and I've just found it to be good hygiene in general.
Is it an issue of it not being of locking the keys in an order?
Yep. Yeah. So for D3, it's going to be about how we access the JSON, and it's never going to. It's going to be very difficult to get data like time points out of the blob. It is fine like this. But I've found this over and over, just with all the D3 stuff and anything else that I've done. I wish someone had told me this 2 years ago. In every page that you're about to see, we have a WebSocket. It's connected to the Tornado instance, and the Tornado instance is just sending clicks to it. And then this is the basic D3 pattern. So these 1, 2, 3, 4, 5 lines constitute the learning curve for D3. So once we're over this set of 5 lines, the rest is as I said, quite nice. I'm going to show you. I'm showing you now in abstract, so that when we see it again with actual fake, probably now, data, you'll spot it. But what we're essentially going to do is use D3 to select a containing element on the web page. We're going to select all the elements inside that container that either exist or that we hope will exist at some point in the future. We're going to bless that selection with some data. We're going to choose, using the enter method, all of the elements that aren't already on the web page but that have data. So basically all of the web page elements that are going to enter the scene we get with the enter method, and then we're going to append elements off that placeholder selection. So that won't make much sense now, but hopefully in another half an hour it will. Okay, so I'm going to have another look at this and just... Oh. Okay, I'm going to be a bit sad. Okay, so what I have as backup, thank God, is called, that I wrote on the train on the way here this morning just because I was feeling nervous, is offline reader. So what this is doing is, instead of reading from the stream, which I cannot believe has gone down, I'm sorry about that, instead of reading from bit.ly stream, it's just generating random latitudes and longitudes and random URLs to simulate the bit.ly stream. Yep.
Like in this particular venue, when you pull off the wireless, you need to re-authenticate on the wireless on a regular basis. That's
Shall I give it a try? Okay.
My internet's working, but reader's not.
Yeah.
So.
Okay. Has anyone tried? I'm going to go over there.
I
And,
just tried curling and I can't.
yeah, so if we just curl this. What a shame. All right, well, all right. We haven't got time to muck about. If anyone notices it come back online, let me know and I'll just switch out the readers, because the last couple of examples, it makes a difference. So, but we'll plod on. Okay, so I'm just sending fake clicks into the system and feel happy that I wrote that this morning. Right, so the first thing I'm going to do is simply get a bit of data from the WebSocket. You can read that at the back, hopefully. what we're going to do is just simply get a bit of data from the WebSocket. So we have to write a little handler to take. Oh, hold on. I've been practicing this. I'm going to type and then I'm going to talk. Otherwise, I'm going to mumble into my chest. So that takes the data, which is just a string, and passes it into JSON. And then I'm going to console log it just so that we can see the fake data. I'm so sad. Okay. Please, if while you're watching me type and you spot something, don't be like, oh, that's sad that he's fucked it up. Just let me know. I have no pride, obviously. So. So what we're getting now is a console log of the data, and here it is. It's going to come in very regularly because it just sleeps for 2 seconds and then sends another one. But what you can see is a randomly generated agent and then randomly generated latitudes and longitudes that could be totally where there are no computers or people clicking. And the rest is all going to stay the same for today, but do have a look in the future when the endpoint is not sucking so hard. So what we've got is these bits of data that are coming in to the browser. I'm just going to turn it off so that we don't get flooded with. So what we've got now is a bit of data, which is just an array of objects, right? What I'd like to do is just make a list of these objects in the web page. So I'm going to join each one of these bits of data to a list element in the web page. So I'm going to first of all select the enclosing element, which in our case is going to be an unnumbered list that I put on the page before. I'm going to think how to move this up. Sorry for those at the back if you're staring at the bottom of. Oh, I can do this, right? So what we've got is we select the unnumbered list. So here it is. It's not very exciting. I would love if anyone knows why its parent node is HTML and not body, given that the UL is inside the body. But if someone could tell me that would be great. So we select that. We can then we select all of the list elements that are in the scene already, which is a bit weird, right? This is the source of a lot of confusion. It's a bit strange that we're selecting all of the list elements that are in our unnumbered list because there are no list elements in our unnumbered list. This is going to give us a placeholder to do some magic with. So there's all our no list elements. We're going to bless that with the data that we got from the WebSocket. So now we've got a placeholder array, but it's still empty. We've just got five of them, and then we're going to use enter. So enter is again is rather. I found it very confusing when I was starting to get used to this. Enter is going to select all of the elements for which we don't already have data on the screen, which in our case right now is all of them. So we're going to get a list of 5 elements, and here they are. Enter will, yep.
I'm sorry, just to point out, because I got slightly lost it, when you were doing the onMessage before, you were actually assigning to a global variable called data.
A global, yeah.
It didn't follow exactly, you're not going to have a data variable right now.
Yeah, if you didn't get any data from the WebSocket, yes. I did assign it to a global because I never really learned how to use the var statement properly. So here's our data, right? So here's our randomly generated click, and we've got 5 of them, and we can hang pieces off this now. So I can append some list elements. Okay, and there they are. So now they've appeared up in my web page. Just to prove it, here are the list elements in the console, and I've got 1 per data point. Okay, and so that's it. That's the learning curve right there, and I'm going to do this for 3 more times today before my time's up. But we've now bound a bunch of list elements to an array of data. So, and now it's all easy. So I'm going to select all the list elements. Oops, I'm going to type D3. I'm going to select all the list elements. There they are. And I'm going to modify their text. And I'm going to put I'm going to use the randomly generated agent that would otherwise be really interesting information about browsers and whatnot. So we need to specify an accessor function and return whatever we want out of the data. And there it is. So what I hope it's clear is that once we've bound the data, yep.
Getting data back from
Oh, no, it's the same fucking thing.
What kind of data were you guys using?
I've never punched the sky before in front of a bunch of people. There we go. That's never going to happen again either. I'm so uncomfortable. Great. Okay. Fucking fantastic. Don't anyone curl this again. Okay, brilliant. That makes it all so much better. Right, great. Anyway, so we've bound some list elements to some data, and we once that data is bound to the elements in the document, it stays bound. And so if we wanted to just switch this out instead of putting the agent, if we wanted to put the URL, which apologies is all going to be the same, we can do that. The data stays bound to the list elements, and we can just access them as required. Okay, so that's the end of the first example. We've bound a data set to a bunch of HTML. I'm going to do the exact same thing, except I'm going to bind it now to a bunch of circles, so some SVG. Have I chosen the right? Yep. So we have already a data set, which, with any luck, is actually real data. So this is a real person just clicked on a real link in a place called Merrick. Don't know where that is. There's another one. This is another click by a real person in a real place called Ankara. So that's great. So we've got that data, and that again lives in a global variable in the console. And I'm going to just apply the same pattern again, except to draw some circles. So I'm going to select the enclosing element. Oh, hold on. I'm going to just turn off the... So I'm going to select the enclosing element, which in this case is an SVG object. There it is. And I'm going to select all of the circles that are in the SVG element, of which there are none, right? There's no circles on the screen. I'm going to bless it with some data, just in the exact same way I did before. So now we have 5 placeholders, and then I'm going to enter this selection. So I'm going to choose all of the circles on the screen for which I didn't already have data. Okay, and there they are. So now these are placeholder values, and I can append a circle, so SVG circle to each one. So so no circles, but what we do have is, with any luck, a bunch of circles with no parameters. So Chrome needs 3 parameters to render SVG circles. So we're going to give them those. So I'm going to use D3 to select all the circles, of which we now have 5. There they are. And I'm going to set its attributes. And so these are setting the attributes of the SVG tags. So we need CX, and I'm going to use the latitude and longitude. And I'm going to set CY, which is the Y value. So you'll see in each case we need to specify this accessor function. And we need to specify a radius. Okay. So, okay, so there's a circle. Can you see it? It's in the top left-hand corner. So we'll go back and have a look at our circles again. you'll notice that these are latitudes and longitudes, so they're from there we go, there's 5 circles that we've drawn with a tiny amount of code. Okay, so these are SVG elements that are bound to data sets, bound to a data set that we got from our WebSocket. Okay, so then the next obvious thing is to do a thing to draw these circles as they arrive, rather than just pulling one out from the WebSocket. I'd like to actually draw them. I'd like to keep track of them as they arrive. So what I'm going to do is just make a slightly more complicated WebSocket handler. Oops, sorry. Let me turn it off for a moment so we can see what we're doing. So I'm going to make a slightly more complicated handler. So we take the event, we get the data, which we need to pass. And then I'm going to do 2 things. I'm going to first append the circles to the scene. And now don't forget that I've got multiple circles coming in, so it's not going to be as easy as just, the enter selection is not going to be as straightforward as it was. So I'm going to append the circles to the scene with a function, which I'm going to define in a minute. And then I'm going to, that function is going to return the selection, and then I'm going to draw the circles. Okay. Okay, so hopefully, yeah. So now it's going to start getting upset because I haven't defined these functions. So let's go ahead and do exactly that. So first we'll, I'm going to select all the circles, of which there might be some. Right now there's not, but we're going to be monitoring this as we go along. I'm going to bless that selection with some data, and now this is the bit. D3 will join by index and lever data to join by something else, which is fantastic. So we specify a little accessor, and I'm going to tell it to join on the agent plus the URL. And so if the same agent hits the same URL, I won't draw that circle. It's a bit blunt, but it works for the example, I hope. So if the same agent clicks on the same URL, it's not going to be, it's going to join with data that already exists on the screen. I'm going to enter, and we're going to append a circle. Okay, so this is joining new data to elements on the screen using a very specific key function, and then appending circles for any new circles that we want to draw that are in the entering selection. And then this is actually going to return that selection so that I can operate on it with the next thing. So unless there are some bugs.
Do you actually want to select all circles, or is it just all specific circle?
Yes, that is totally a bug. Thank you. I want to select all circle. I said circles out loud. How's that? Okay, I think that's good. So now it should complain that we don't have draw circles defined. I'm going to move this up just so everyone can see. So I'm going to make the function whoa. And then this is going to be the exact same thing as we did before, so I'm just going to specify the x and y and the radius. So this will just take a moment. We need to do the same trick as we did before. Note that Bitly disagrees with Bitly writes latitude and longitude, and we're going to have to often write longitude and latitude. So that's something to watch out for. So we're going to, okay, so we've set the we've set the X, we need to set the Y. And set the radius. And this is a function, so I need to close it. How's that? Okay. So that should be all we need to start drawing circles. So every time we get groups of 5 clicks from Bitly, Tornado is going to send them through the WebSocket, and we draw the circles as they arrive. Okay, so there they are. So with not much code, so with me standing here I've been talking for half an hour, but with a relatively small amount of code, we're now monitoring live clicks from Bitly in a way that's not making a great deal of sense right now, but will make a lot more sense when we draw a map. But I just want to kind of point out how once we're over that initial bit of learning curve, this isn't a great deal of work to be doing. Okay, let's draw a map. So D3, and I'm not terribly sure why, but D3 has an amazing amount of geographic projections in it. So if when you're drawing geographic things, D3 seems to be especially good. And I'm not sure if that's because Mike Bostock joined the Times and started drawing lots of graphs, maps or something. But there are many, many different types of geographic projections, and there's a library that makes it very easy to draw maps, as we'll see. So the first thing we need to do is to specify a projection. So this is going to map latitude and longitude onto the space of pixels in the screen. D3 has a lot of ideas about scales, which map from the space of our data onto the space of pixels. A projection is one specific type of scale. It happens to live in the geo package. And then, I don't know if anyone can pronounce this, but I tried and I can't. Notice that this generates a projection, so this returns a function for me to use later. And I'm also going to specify a path generator. SVG paths are a pain. D3 provides a couple of path generators that we can use to instantiate SVG paths without having to go through all that pain. The geo path accepts a projection, which is great. That's that. So path, again, is now a function that I can use I'll give it latitudes and longitudes, and it's going to give me back an SVG path in the space of pixels on the screen. And then to draw the map, we just have to apply the pattern, right? So I'm going to select the enclosing element. I'm going to select all the path of which there aren't any. I'm going to bless it with the data. I'm not going to go through this right now because it's a bit painful, but there is already in the namespace a geometries JSON, which comes off the back of a thing called topo JSON, which Bostock has already written, and is really good. But it's out of what I'm going to be talking about today. I'm going to enter. I'm going to append a path element. So this is SVG, and then the path takes as attribute D the data it needs to render the line. So, and we give this attribute the path function that we generated, which is going to take this big list of latitudes and longitudes in geometries and render the map. I hope. There it is. Okay, so we use this projection and a JSON file that I already had in the namespace to generate a map.
What's the URL for this? Is it /map?
For this is map 0, yeah, 0.
I didn't have a geometry, so I got really confused.
Oh, right, sorry, yeah, there's another map that's going to be shinier in a moment.
So the outline is the Russian sampling projection?
Yeah, so the projection is the thing that takes our latitudes and longitudes and maps them onto the space of pixels. So It's a special kind of scale because it's taking latitudes and longitudes from spherical coordinates and mapping them into just Euclidean coordinates on the screen, Cartesian coordinates, whatever, pixels on the screen. So the main thing I wanted to just show you with the map is that we, by applying the pattern and using the projection, we can actually draw quite complex SVG. So don't forget this is vector. Oh, here we go. So these are all individual paths that we can reference and muck about with and color differently. This is an SVG map. So obviously we're going to want to put it all together. So I've already drawn the map in this screen. I have a callback that's waiting for the draw circles function to be defined. So we've got a callback in the WebSocket onMessage handler, so waiting to draw the circles. And we have to do a little bit of work now to draw the circles on this map to make sure that they're in the same, using the same projection. So I'm going to define this function. Oh, just to make it clear, I have therefore a variable called circles which contains all of the circles that are ready to be drawn, and that always exists in this namespace. So we're going to draw circles, and it takes in that selection of circles that's ready to be drawn. And this bit is an annoying amount of typing because we need to flip the latitude and longitude supplied by Bitly to the other way around. The projection takes both latitude and longitude. I'll write and then you'll see. So we want to do return. We use the projection that we set up, so that's the projection that I can't explain, that I can't pronounce. We need to send in the second element of the latitude and longitude, and then the first element, which is just annoying. Bostock and Bitly disagree on which way these things should be ordered, and then we select the first one, which is now the X position in the pixels on the screen. Okay, and then we need to do the same with the Y position, except select the second element. And then we need to set the radius. And then finish the function. Does that look good? So now every time we get some clicks, it's going to take the latitude and longitude in the clicks, map them through the projection and onto the pixels on the screen. So we can start keeping track of where these clicks are coming from live. So every time a new piece of data comes through the WebSocket, all we need to do is update only those circles that we need update. So we can throw a lot of circles through this pipe, and this is going on right now, right? This is live. These are real people clicking on real short links all over the place. Okay, so I'm at 40 minutes. I've got one more little thing that's more bling than useful, but we're going to do it anyway. It's fun to have some animation. And D3 is fantastic at animations and interactions. I haven't got to the interactions in this talk, but I would quite like some animations. So I've put another function into the WebSocket handler that is going to animate the circles as they arrive. What this example also attempts to show is that we can affect the CSS of all of these, so we can affect the styles of all of these elements in exactly the same way that we can affect their text and their attributes. So I'm going to start off with setting the opacity of all these circles to 0 and the radius of all these circles to something big. And then I'm going to tell D3 that I want to transition. I want to transition over this many milliseconds to an attribute with radius 4 and style opacity 1 so that we can see them. Okay, and with any luck, we can start getting animated. Did that work?
Yep.
I didn't see. Okay, great. So, so with a really small amount of data, we can get. It's a bit blingy, but like you can, it's these kind of visualizations we've been chatting about before. These kind of visualizations are useful for getting a feeling for what's going on in your systems and what the whatever you're looking at. It gives you a nice sense that activity is occurring. I wouldn't necessarily be taking any business decisions or operational decisions off of visualizations like this, but we do get a sense for the amount of traffic we're getting, where it's coming from. These are all of the government short links that are shared. It's the US government short links that are shared. So people are clicking on NASA, they're clicking on the weather, they're clicking on immigration, tax, all to do with the US government. And so I think it's really fascinating, and I find it really exciting that I can build these things with D3 really quickly and easily. So just to recap, and then we'll get on. We had a look at a WebSocket on-message handler. We drew some circles, which weren't particularly exciting. We talked a little about using a key to join data against something that's not just index, so that we could draw more and more things each time new data arrived. We drew a map of the world, which was a way of talking about the projections and scales and paths. And then we put it all together by using the projection that we'd built up before to map the latitude and longitude in the data onto the space of pixels. And then we added some fancy bling. So just to finish up, the D3 homepage is fantastic, and you should check it out. And there's loads of beautiful stuff, and the API docs and everything's there. It's fantastic. You should check it out. Scott Murray writes really brilliant tutorials, and you should check those out, as well as his book, which is a lot about D3, but has a lot more information about visualizations generally on the web. Jason introduced me today to this Dashing D3 tutorial page, which looks really good. And then there's two products that I thought I'd mention. Cubism, made by Square, which you may have come across for updating time series plots, and then which was I think written by Bostock while he was at Square. And then this thing that's quite recent, that's new, called, I don't know how to pronounce it, maybe Bokeh, that is plotting using D3 from Python, which I think would be really good, so we don't have to do too much JavaScript and do more Python, which is a good thing. Okay, so that's me. Thanks very much for watching me type. I don't know if we've got time for, is anyone kicking me off? Yep.
Are you responsible as a programmer for making dots go away? Like,
Yes. Yeah, absolutely.
If that's the case, you could try to set D3 at some point, just magically make those fall off.
Oh yeah, so you don't, it doesn't have to be magic. You can, there's a dot remove method on selections, so I can put in a delay of however long I want the circles to last for, and then dot remove against that selection, and it has I think it has quite a big system of timers in there that's keeping track of all of the timers associated with all of the selections. With this data, it takes a long time for the browser to crash. In fact, the reader crashes before the browser crashes. But with New York Times data that we've been plotting page views, and that you have to make those circles go away really quick. Okay, great, thanks.